In our previous class, we discussed acid and bases, and we also discussed the calculation on the pH. Today, we are going to look at salt. What are salts? Let us look at this equation. From the previous class that we had, what type of substance is this? An acid. What type of substance is this? Base. Now that means we are reacting an acid and base together. What is formed here is what? Salt. Now we can say a salt is formed when the replaceable hydrogen of an acid is replaced with a metal or ammonium ion. So a salt is a substance formed when the replaceable hydrogen ion of an acid is partially or completely replaced with a metal, or ammonium ion. A substance formed when the replaceable hydrogen ion of an acid is partially or completely replaced with a metal or ammonium ion. I hope you get that. You can say that this salt is formed when the hydrogen present of this acid is replaced with sodium, which is a metal. So a substance formed when the replaceable hydrogen ion of an acid is completely or partially replaced by a metal or ammonium ion is called salt. Now let us look at types of salt. Types of salt. Types of salt. One, we have normal salt. Two, we have acid salts. We have a basic salt. Four, we have a double salt. We have complex salt. Normal salt, acid salt, basic salt, double salt, and complex salt. When do we have a normal salt? A normal salt is formed when the replaceable hydrogen ion of an acid is completely replaced with a metal or ammonium ion. An example is given like this. Then we have H2SO4 combining with potassium hydroxide. This is an acid. How many replaceable hydrogen ions do you have here? So if all the replaceable hydrogen of this acid is replaced with the metal from this base, what is formed is referred to as the normal salt. So we have K2SO4 plus H2. Therefore, this is an example of a normal salt. Because all the replaceable hydrogen ion of this acid is formed is replaced by what? By the metal from this base. So we refer to this as a normal salt. I hope that is clear enough. Who doesn't understand? We can have another example here. Next we have CH3COOH plus NaOH. How many replaceable hydrogen do you have here? One. So if this hydrogen is replaced with a metal, the salt form is going to be a normal salt. So we have a CH3COONA plus H2. So this is also a normal salt. You want to ask questions?
Is ammonium chloride a normal salt?
Ammonium chloride. You see, when you have ammonium chloride on its own, it's supposed to be a normal salt. But solution of ammonium chloride is going to be acidic. It depends on what you are given. If the question does say, what is the, if I say, classify the following into acid or normal acid or normal or acidic. So in that case, it is given like this, NH4Cl. This is a normal salt. Am I communicating? But by the time this solution, this salt is dissolved in solution, the solution becomes what? Acidic. It is the solution of this salt that is acidic, not the salt itself. Look at this. Na2CO3. It's not the salt. What type of salt is it? It's the normal salt. But when you dissolve it in water, it becomes what? The solution becomes what? Alkaline. Two different ways. If you are talking of hydrolysis of the salt, when you hydrolyze the salt could be either acidic, it could be normal, or what? Or basic. But we are talking of how the salt was formed. You can have the salt could be either normal, acid, basic, double, or complex. Don't mix the two together. So both this ammonium chloride and the sodium trichloride, they are normal salt. Though the solution of ammonium chloride is what? Acidic. While the solution of sodium trichloride is alkaline. We are going to discuss this one. We are still going to look at hydrolysis of salt. You will see the reason why the solution of this one is acidic and why the solution of this one is alkaline. So we'll move on to the next one, acid salt. When do we have acid salt? When the replaceable hydrogen ion of an acid is partially replaced with a metal or ammonium ion, the salt form is called an acid salt. We have H2SO4 plus NaOH. This is a dibasic acid. This acid has two replaceable hydrogen ion, right? If it's one of its hydrogen is replaced with sodium, which is a metal, we are going to have NaH. That means out of two, one is gone with what? Metal. Then you have what? SO4 plus H2. This type of salt is called acid salt. So an acid salt is formed when the replaceable hydrogen ion of an acid is partially out of two. One is replaced with metal. So we call this one an acid salt. It is different from when all the replaceable hydrogen ion is replaced. When all the hydrogen ion of an acid is replaced with a metal, what you have is called what? A normal salt. In that case, for an acid salt to be formed, the acid required must be dibasic or tribasic. A monobasic acid cannot form an acid salt. Are we together? Acid like HNO3, which is monobasic, HCl, which is monobasic, CH3COOH, all these, each of these acids is what? Monobasic. They cannot form an acid salt. Because when they combine with a metal, that one hydrogen that is present will be replaced. And what they will form is what? It will be what? A normal salt. Now let me give you a question here. Which of the following acid, which of the following acid will form an acid salt. Okay. Now, which of the following acids will form an acid salt? You have AH3PO4, BHCl, C6H3COH, then DHNO3. Yes? Is what? All the other acids there, they are what? They are monobasic. And monobasic acid cannot form an acid salt. I hope that is clear. So let's move on to the next one. We have basic salt. Most time when you are having acid react with a base, you are reacting acid react with a base. What to form is what? Salt and water. And salt and water will form normal when the required number of acid neutralize what? The required number of base. But when there is an insufficient acid to neutralize a base, the salt will be formed. But the salt form is called a basic salt. That means instead of you using 20 centimeter cube of acid to neutralize 25 centimeter cube of base, if you use 15 centimeter cube, the salt that you are going to form is going to be a basic salt. So a basic salt is formed when there is an insufficient acid. A basic salt is formed when there is an insufficient acid to neutralize base. And there is insufficient acid to neutralize base. Then you have what? A basic salt. Most time when you have a basic salt, there will be presence of hydroxyl ion. Usually what the acid is doing is to take away the OH from the base. But when there is not enough hydrogen ion to take the OH will still be with what? Will be with the salt. Then the salt becomes what? The salt becomes what?
Basic salt.
You have zinc, OH, Cl. Ordinarily, when there is enough acid to neutralize the base, what you are going to get is what? Zinc chloride. But what you have now is what? Zinc hydroxyl chloride. If you add more acid to this, the hydrogen ion in the acid will take away the OH and it will form water. Or you can have MgOH then Cl. All these ones are examples of basic salts. And they are formed when you don't have enough acid to neutralize the base. Shall we continue? Now move on to double salt. As the name implies, it has to do with what? Two salts. So double salts are formed when two simple salts, usually of the same anion, are mixed together or are combined together in a stoichiometry ratio. Double salts are formed when two simple salts. Double salts are formed when two simple salts are mixed or combined in a stoichiometry ratio, and these salts must have the same anion. This is what I'm trying to say. I have Al2SO3 dot 12 H2O, or let's say this one, together with a K2SO4. We look at this salt. We have potassium ion, that is potassium tetrahydrolysis, and this is aluminum tetrahydrolysis. What is common to both salts? So that means they have the same anion. So when these two mix together, the salt that will form is going to be what? So the salts you want to mix must have the same anion. And when the two are mixed together, you are going to have KAL bracket SO4 into 2 dot 12 H2O. Usually, these salts are referred to as alum. This is potassium aluminum tetrahydrolysis through decahydrate. So how do we get the salt? It was formed by combining aluminum tetrahydrolysis and what? Potassium tetrahydrolysis in a particular stoichiometric ratio. Central atom that is connected with several atoms which are referred to as ligands. For example, we have copper bonded with ethane. We have, you can see the central atom there. This is copper tetraamine. This is the central atom, and this atom attached to them is referred to as ligand. So another example is a potassium hexacyanoferrate 2. Or you can be 3. You can also have K3FeCN into 6. Which one is going to be central atom here? In these two compounds, which will be central atom? Ion. Which one is going to be ligand? Cyanide. The central atom here will be ion, and the ligand, the atom that attached to them, is going to be the cyanide. So they are referred to as complex salt. Now, if you are asked to give type of salt, you're supposed to know. Now, simple classwork. Classify the following. sodium chloride. It is what? Normal salt. Then 2, basic salt. That is okay. Third one, soluble salt. That is also right. Then number 4, normal salt. Yes, normal salt. Then number 5, also normal salt. Then number 6, acid salt. Then number 7, this one is complex. Then number 8, normal salt. It's normal salt. Number 9, normal salt. Then number 10, acid salt. That means if you are given salt now, you know how to classify it into the kind they belong. Now before we go into the let's look at the preparation of salt. Preparation of salt. Preparation of salt. Now, preparation of the method chosen to prepare a salt depends on the solubility of the salt. That means you can classify preparation into 2: soluble salt and insoluble salt. How do we prepare soluble salt? And how do we prepare insoluble salt? Then how do we know which salt are soluble and which salt are insoluble? Let's first of all look at soluble salt and insoluble salt before we look at how we can prepare them. Now, the following salt, that it is easy for us to know the salts that are soluble and the ones that are insoluble. Now let's look at all salts of trioxonitrate 5 are soluble. That means all trioxonitrate 5 salts are soluble. So if you say potassium trioxonitrate 5 is going to dissolve in water. What is this soluble salt? When you add the salt in water, will it dissolve or not? If a salt dissolves in water, it is. If it does not dissolve, it is what? Silver trioxonitrate 5. Is it soluble or insoluble salt? Lead trioxonitrate 5. Is it soluble or insoluble? Soluble. Because we are saying all trioxonitrate 5 salts are soluble. Now let's look at all tetral oxosulfate 6 salts are soluble, except those of what? Except those of lead and barium. Calcium is slightly soluble. That is why I say sodium tetraoxosulfate 6. Go to the what? If I say magnesium tetraoxosulfate 6. If I say aluminum tetraoxosulfate 6. If I say barium tetraoxosulfate 6. If I say lead tetraoxosulfate 6. If I say calcium tetraoxosulfate 6. It is slightly soluble. Now, silver trioxosulfate is also what? Soluble. I've only moved up just this one. Now let's look at all trioxocarbonate 4 salt are insoluble. This one are what? Insoluble. Except those of sodium, potassium and ammonium. ammonium salts are soluble. All sodium salts are soluble. All potassium salts are soluble. Just like all trans-rectified salts are soluble. Is that okay? So when you now talk of carbonate salts are usually insoluble. But if it has sodium, potassium, or ammonium, it becomes what? Because we have said all sorts of potassium, sodium, and ammonium, they are soluble. If I ask you which of the following salts is insoluble in water? Which of the following salts is insoluble in water? A. So which of the following salts is insoluble in water? Which of the following salts is insoluble in water?
No.
Which of the following salts is insoluble in water? That is no. All of the salts written there, they are all soluble. Is that again?
Yes, sir.
Talk of which other one I've not mentioned?
Chloride.
Chloride. All chloride salts are what? Soluble. Except silver, lead, mercury, and copper 1. Copper 1 chloride is insoluble in water, but copper 2 chloride is soluble. Is that okay? All tri-oxo-sulfate 4 salts are insoluble except those of potassium, sodium, and ammonium. So that means if you know the salts that are soluble, I know those ones that are not insoluble. If I have to measure the method we use to prepare a salt, you know the method to choose. Are we together?
Yes.
So now, before we call this a day, yes?
Are all sorts of sodium, potassium, and ammonium, are these?
I've said it here. All sorts of sodium, potassium, and ammonium are all soluble. That is why where we say they are insoluble, we wrote except those of what? Sodium. You can see, look at this one here. Where we say they are all insoluble, we have used exception of sodium, potassium, and ammonium. Here again, you can see the exception that I have written here. Or let us include it. All sorts of sodium, potassium, and ammonium are soluble.
Why? Is it not their electropositivity?
They are highly electropositive. That means most of bonding form is good with what? They form ionic, and ionic salts are what? Are soluble in water. Is that okay? So, which of the following salts is insoluble in water? Which of the following salts is insoluble in water? So which of the following salts is insoluble in water? AgCl. Because I said all chloride salts are soluble in water, the exception of that of silver, lead, mercury, and so when we meet next class, we are going to discuss preparation of soluble salt and insoluble salt. So we meet again next class. Please enjoy the class.